Hello everybody and welcome to Pisa Presents. Today we're going to be looking at some really big birds. Well, Gastornis and the rise of giant fossil birds. Now, this of course is a bird. Cute little fella, isn't he? But they didn't always look like how many picture them. Now, at one time birds, and I mean what would be a proper modern bird and not say like Archaeopteryx with mostly reptilian features, could be a lot bigger. Look at this fellow right here, Dromornis. That is an Australian giant that grew up to 10 foot tall and weighed about 1,000 pounds or more. Now, the second largest flighted bird known right here is Osteodontornis. Now, he looks rather angry and looks like he wants to spend his time mugging people in the Miocene, but you know what? People have to start somewhere. And even history's biggest parrot, known by the non too subtle name of Heracles inexpectatus, or by the way, I'd like to point out that this is also known by the utterly awesome name of Squawkzilla, which I just find completely hysterical. Altogether, prehistory is filled with lots of giant birds, so that really raises three questions. Well, how did they evolve? Why did they get so big? And what happened to them? I mean, why did they go extinct? Now, first of all, we're going to look at how did these birds evolve. So in order to see that, we're going to look into how birds evolved, period. And in order to do that, yeah, we're going to have to look at pretty much what has to be one of the best public domain images ever, which I swear to God, I still cannot laugh looking at that. I just find that utterly hysterical. Now, so serious kudos to whoever came up with that. Now, among legitimate scientists, it is pretty much universally accepted, notice how I said accepted, that birds have evolved from dinosaurs. While it's not the hop, skip, and a jump from T Rex that some movies make it appear, birds evolved a lot slower over millions of years through the theropod lineage of dinosaurs, of which Tyrannosaurus is one of them. Not really necessarily Tyrannosaurus, but other theropod dinosaurs instead. T Rex actually didn't even have fossils, by the way. So it wasn't like one day a Rex just kind of hatched something like that and boom, you had birds. No, there were many, many steps over several million years, which scientists still argue about very much to this day, and honestly, I think they always will pretty much argue about. Now, some of the species that we're going to cover later on, you'll probably notice if you look them up, were actually fairly recent discoveries. So, why the sudden interest in these giant fossil dinosaurs? Well, that's because it's due to what I'd argue would be the pretty much one of the most influential moments in science of the past century. And yeah, I mean Jurassic Park. Now, love it or lump it, yeah, while the movie wasn't perfect, like Velociraptor was famously really, really upped in size quite a bit. Because, I mean, you couldn't say have it fighting the likes of Samuel L. Jackson when in reality it was the size of, well, okay, a turkey. Now, that movie really, really increased a lot of interest and a lot of scholarship into much of the origins of not only the birds, the dinosaurs, just giant birds in general. So, modern birds, first of all, began appearing about 150 million years ago, so even way before the time even of T Rex. Now, how did they come about, and really, what are the features that nowadays we link from dinosaurs that birds have? Well, first of all, they have feathers and other soft tissue. Lots of famous dinosaurs, like, say, Velociraptor and others, actually had feathers. There's also other soft tissue that is basically passed on down to birds. So you can look up various lineages, and the only other creatures that have these soft tissue features are dinosaurs. Now, another one is how they evolved flight. So you look at how, say, bats or pterosaurs fly, they didn't really evolve those wings from their forelimbs like birds did, and like a lot of bird like dinosaurs, like, say, Archaeopteryx, which is now classified really as a reptile, or just like that, a not really a bird, but more so a dinosaur instead of the other way around. And then also, too, we have, well, they're bipedal egg layers. You got two legs, two eggs, and golly, I cannot talk today. So you have two legs and they lay eggs. Yeah, try saying that 5 times fast if you stammer a little bit. Now, also, too, the metabolic rates and body temperature. Simply put, a lot of the dinosaurs at the time, they had to have been warm-blooded. Elsewise, they could not have fed the internal systems that they had. And also, too, birds are obviously warm-blooded, which leads you to believe that their ancestors were as well. Also, various other ways that they had of controlling their metabolism just in general are things that they really had to have inherited from dinosaurs themselves. Now, obviously, all things have to come to an end. And while by the time the dinosaurs went extinct, there were several other lineages of creatures, such as birds, mammals, what have you, coming underway, that still begs the question of, well, why did some survive the extinction and why did some not? Now, some people theorize that the key to the rise of the early prehistoric birds is just the KT extinction itself, and really it boils down to mass. If you look at the creatures that survived the event, which was okay, so, well, first of all, here, like, why is it that whenever they show that about to hit Earth, they always show like a Tyrannosaurus there that looks like Travolta in that Pulp Fiction GIF, just very blankly looking around, like waiting to be smacked in the face into oblivion? It's, I don't know, I hate that. But so you have about 65, 66, some will tell you, million years ago was the end extinction. And really, around, say, like 30 odd years ago, even a lot earlier into the 50s, 50 something million years ago, you started to see a lot of, well, rather large birds filling the ecosystem. So places like Antarctica, New Zealand. Oh, New Zealand has a lot. They got some really cool stuff. We'll get into that in a sec. Australia, North and South America, China, and even Europe, they all had very large fossil birds. Now, so the question begs, well, why did they get so big? Obviously, it was a bit of a time gap. You didn't just have dinosaurs went extinct and then boom, you had ginormous birds running around the planet. No, you didn't. It took a time for them to evolve. And part of the key to that, here's three of them, by the way, and just in case you're wondering, today's top three largest birds are the common ostrich, the, oh, darn it, there's another ostrich. Sorry, I'm missing something right there. The Somali ostrich is number two, and the southern cassowary is the third largest bird on Earth right now. Now, these guys, yeah, they predate them by quite a bit. So, how did you get from one to the other? Well, one of the reasons is potentially continental drift. Now, at the time the dinosaurs went extinct, and really throughout history and later, the continents you see are always moving. So things don't look the way that we picture them today. The shapes of the continents, coastlines, how they're laid out, everything is ever changing, which is utterly awesome. So, really, I mean, the position of where we are on the earth right now is never going to be the same again. And it's like that back at the time of the rise of the giant birds. So if you look at the lower left with the Cretaceous period, you can kind of see what becomes Australia, New Zealand, Antarctica. Yeah, they're kind of sort of close to each other, which probably kind of explains how a lot of similar species were found on these various continents that now are much further apart. Of course, they were able to somehow perhaps find a way across the land, but still, all these landmasses are isolated. So that isolation leads to speciation. It leads to people being able to fill, the term is a niche. So when the dinosaurs went extinct, they left open rather, sorry, a very, very big niche. And a niche is basically, think of like a footprint or a role in an ecosystem. So you left pretty much a lot of apex predators wide open. And so that space was open. And these birds, a lot of these bird lineages, basically saw an opportunity, and so they evolved to fill the niche that the dinosaur extinction had left behind. So you were able to get quite a few big birds. Now, also too, you have to keep in mind that while yes, you did have mammals at the time, you didn't have, say, the Pleistocene megafauna like that bad boy right there that you did a couple of million years later. So these birds were able to get really big simply because of a combination of the fall of the dinosaurs and also too the various land masses that they were on being isolated. You didn't really have, they were isolated from predators, from a lot of other things. So they were able to specialize to their environment and get really big. Now, some of the ones that we're going to look at are following a nice lucky 13 that I picked of some giant birds from all around the world. We're going to start looking at with Argentavis. Now, that was about 9 to 6.8 million years ago. This was in Argentina and is potentially the heaviest flighted bird. Keep that in mind, flighted bird in history at about 150 to over 180 pounds. People kind of argue on the size of it because the fossils, like many of the organisms following, it's not like you find a complete skeleton because still there are bits and pieces here and there, so you don't really find a complete whole skeleton of what a lot of these birds looked like. So sometimes it's hard to differentiate the size, and when you look up some of these, like in books and what have you later on, you may notice a lot of divergence in, say, some of their characteristics. That's just simply because of people extrapolating these body parts differently. So, Argentavis was a relative of today's condors, and it had wingspans of about 20 feet. Now, then we look at the Dromornithidae. Oh, golly, I really cannot talk today. Now, they are also known as the Mihirung Thunderbirds or, quote, demon ducks of doom, which, no, I am not kidding at all on that one. Now, this specimen right here, blackened eggshells. Now, these are blackened eggshells of the Afroshoned Gastornis. Now, so why would these eggshells be blackened? Because there were giant birds on this earth when mankind was on this earth. And a good portion of how people reason they went extinct is, well, predation. Because you know what? Eggs are pretty nummy. And these eggshells were found in basically an area where it was obvious that early man had done a lot of cooking. So they came along, found this egg, was like, wow, we're eating good tonight. And that pretty much led to the extinction of several species. Now, another species in that group is also known as Serton's thunderbird. So that's about 9.8 feet tall, weighed over 1,100 pounds. Now, that particular one right there was, well, the group in general was mostly from Australia. You're looking at the Oligocene to the Pleistocene. Like I said, some of them are around when mankind was around. And they're an accepted 8 species and 4 genera. Now, and actually, what's really amazing, they are a sibling or even a cousin group to the ancestors of today's waterfowl. Yes, those ancestors diverged about 50 million years ago, but can you imagine the likes of that just basically paddling up to you in a pond someplace, like looking for breadcrumbs? Okay, so I think it was cool, but some other people might pretty much pee themselves and run away. Now, elephant birds, the largest birds on Earth ever, period, pretty much. Now, they're natives to Madagascar, which, of course, is an island famous for developing some pretty unique species, in no small part due to its geographic isolation. Now, they were from the Quaternary period, and they ranged from about 180 to 2,200 pounds. Yeah, that's a really big bird. Now, here's a comparison of some of these species right here, and you'll even have in here a few dinosaurs as well, like Deinonychus down in the dark blue. The green is Utahraptor, and then there is the Epyornis, is the elephant bird. Now, that's the really big guy. That one was 9.8 feet tall. That one you may see go by what's referred to as a more obsolete name right nowadays. It's kind of complicated. One of those things where people name in various body parts of fossils that turned out to be actually the same fossil as something else that was already named. You may see that described as Titan, but that is actually a obsolete name for the fossil. Now, Gastornis. This is a very, very lovely creature. Various countries, about 60 to 56 million years ago, once it was famously known as Ditryma. That was the name that actually Edward Drinker Cope gave it when he found some of the fossils. Now, its largest species weighed about 390 pounds and was over 6.5 feet tall. Now, it's popularly known as the terror bird, but it is not in the same group as the group known as the terror birds, which we'll get into later. So its nickname is the terror bird, but it isn't in the group that's known as the terror birds. Now, giant penguins. This is absolutely so freaking cute, like I cannot tell you. There is something that I find so wholesome about absolutely gigantic 6 foot tall penguins just hobbling around the world 60 million years ago. It is utterly precious. These were also in New Zealand, various species, and also too the notable one from Antarctica, which weighed 256 pounds. The biggest early penguin, well, the biggest penguin period, 340 pounds. That, my friends, is a lot of penguin. Now, the giant petrel is from New Zealand, and it was about 3.4 to 3.06 million years ago. There is its skull. You can kind of see from the front, the D picture there, how it had that very well-defined beak. Now, here is the aforementioned Heracles inexpectatus, which basically that name kind of boils down to, holy crap, we really didn't expect this thing to be so big. How big? Well, this is a really big parrot. Once again, it's found in New Zealand, surprise, and it was from 19 to 16 million years ago. It was 2 foot 11 inches tall and weighed 15 pounds. So Polly can win a lot of crackers. Now, the moa is another famous one from New Zealand. You're looking at 9 species and 6 genera. Now, they ranged from about 17 million years ago to the Holocene, and you can just get a sample of some of them right there. Like number 1, the red one, is Dinornis, and also 4 is another species of Dinornis, Dinornis robustus. So these really dwarfed. Man, it's actually, yeah, it's really, really neat just thinking of just the variety in Earth and how these animals were able to specialize. Here is our friend from before, Osteodontornis. Now, relatives of pelicans, storks, and lake waterfowl, they were from about 20 to 6 million years ago. Now, Osteodontornis ori is the second largest flighted bird known. Remember, we had like the first a little bit earlier, and it had a wingspan of 18 to 20 feet and was nearly 4 foot tall. Now, Pachystruthio was found in Asia and Europe from about 2.6 million years ago to the Pleistocene. You may look at that and think, well, gee, that's an early ostrich. Actually, not really. It may look like an ostrich, it may be called the giant ostrich, but it's not necessarily an ostrich. That's being debated. Now, this particular species, the giant ostrich as it was known, was 11.5 feet tall and weighed 990 pounds. Now, Pelagornithidae was, how did I say that okay, and I couldn't say egg earlier? How the heck does that happen? Now, alright, so these ranged from 62 to 2.5 million years ago from numerous countries. They were known for their teeth-like struts. They didn't basically have teeth in the beak, but instead they had these bony shapes that were called struts. Now, Pelagornis sandersi had up to a 20-foot wingspan. Here it is compared to the Andean condor on the left and the wandering albatross on the right. Now, the terror birds, mentioned those from before, Forsokids, and other pronunciations from that. So they were from about 53 to 0.1 million years ago, stood up to 10 foot tall in numerous countries. They're found from all around lots of places. That one right there is Titanus walleri. Now, Teratornis or it means wonder birds. So North American wonder birds of the Pleistocene. You look at that picture right there and you may think, well, okay, that's an early vulture. Again, they're not really sure now. For one time, they were actually classified as vultures. Now that's up to debate. This specimen is found, well, its most frequent fossil site is actually the La Brea tar pits, an absolutely awesome place that I definitely recommend everybody going to. Now, that particular specimen had a wingspan of about 11 to 12 foot and weighed upwards of 50 pounds. Now, obviously, like the dinosaurs, all of the giant birds came to an end eventually for reasons which you kind of already went into indirectly, whether it be their eggs being eaten by humankind, or in the case of a lot of our larger waterfowl, over time you had the rise of a particular group of animals known as the whales, which then outcompeted, outpredated them, also to the sharks. You know, sharks are not going to take very kindly to somebody being in their region. So, between basically predation, competition, and really just the simple fact that they got too big for their own environment, eventually our friends the giant birds fell underway. And still, I hope that sometime you're able to look at, say, a place like the La Brea Tar Pits or elsewhere and just consider the birds of today versus the birds of yesterday and see really how far we've come and, in many ways, how much smaller we've become.